Welcome guys, it's Miss Brown and today I'm going to talk to you about Hooke's Law. Now Hooke's Law is a rule for forces and it deals with the forces that are on a spring or some sort of stretchy material. For instance, I have a spring right here, and what would happen if I were to stretch this spring? I'm pulling a force down, but everything's balanced, it's not moving. There must be a force coming up. So how can we quantify, how can we measure that force from a spring? Now this rule will work for a spring, it'll work for a rubber band, anything that's stretchy. Sometimes it's called the elastic force. Here we go, right here is our equation. F equals negative K times X. Nice and short. The F stands for the force. Elastic force. And because it's a force, what unit will we use? You got it, the Newton. All right, when we get to K, K is often called the spring constant. The different springs are stronger. The shocks in my car are going to be harder to stretch out than this spring. And even if I compare two different springs right here, and I put the same amount of mass, so the same amount of weight, the force of gravity. So here's, this one's thicker. You can see how much that one moves. Let's see how much that changes. And if I look at this little teeny spring, what's going to happen? Oh, that's a bit too much mass for that spring. So different springs have different strengths. And the way that we quantify that is this constant K. So the units of K will be in newtons per meter. And this varies depending on how strong that spring is. And this last one, X, is going to be how much that spring stretches out. So if I could put a meter stick in front of myself and see how much, so this, right now this is at what? 86. And if I stretch it out, it will go down all the way to, let's see what that is. Looks like 73. So if I found that change, that extension of the spring, that would be the X. So X, let's write that down. It's the extension of the spring. And that will be a length, so we'll do that in meters. So, here we go. Let's do this problem. So, oh, hey, this negative sign. Jenna's going to ask me about this negative sign. So this negative sign, why is that a negative sign here? So let's think about it. Which way does my spring pull? So the extension of the spring is down. Which way does the spring pull? The opposite direction. It's pulling it up. So that's why there's a negative sign, because the force is opposing the extension, or some springs can compress, like the shocks in my car. So the force always opposes that change in the length of the spring. And so that's why there's a negative sign. So what is the X for this problem? With this, so we said it was at 86, and then it was at what? 73. So that's 13 centimeters. I want my X in meters. 0.13 meters. Now, what is the force that is pulling down here? Good question. It's not, if we let it stop bouncing, it's not moving. So they're balanced. The up force is the spring. The down force is from gravity. So what's the mass of this? I don't know if you can see. 200 grams. So the mass is 200 grams, it's the same as 0.2 kilograms. So the force up from the spring is the same, it's the same as the force that's down from gravity. So that's m times g equals 0.2 times 9.8. So that's going to give me 1.96 newtons. So I know the mass, which I use to find the gravity. Here's my force, here's my x, and now I can find k. So hopefully I have room. So if I want to get k by itself, I need to take and divide both sides by x. So k will equal the force divided by x. And so the force is 1.96. X was 0.13. I think it's going to be 15. I have a feeling Jonathan already knows probably. 1.96 divided by 0.13 equals 15. I know this. Good. So this spring has a spring constant of 15 newtons divided by meters. And there we go. You can use this equation to find a few different things, and I'd like you to do that. So please begin the Hooke's Law practice page. You guys can do this. I believe in you. Give it a try.